Hello, Internet. My name is Bret, and I'm here on the YouTubes. Another week and another Docker and DevOps live show. So the way this works is if you're here live, you get to ask questions, and myself and my guests will try to answer them, and we will have a conversation about whatever the topics are, and we might go down rabbit holes. We might just talk about whatever, and that's the way this goes. And then this show will turn up as a podcast. You can listen to that on my podcast as well, so you see all the description information below. You can get things at the URL above, and so let's just get to it. Ask your questions early. We'll get to them in order as we talk throughout the show, and let me bring in my very special guest, Liz Rice from Aqua Security.
Hello. Hi. Thanks for having me.
I'm glad you're here. In case you haven't seen Liz all over the internet, let me give you a brief introduction because for those of us in the container community, we see her face often.
Right?
So Liz has been working with container technology since 2014 and is perhaps best known in the Docker community for her live coding talks explaining how things work in containers. I've seen this, and it's actually a really cool talk. So look around YouTube for Liz Rice, and you'll find dozens of videos about this kind of stuff. It's pretty cool. She's been with Aqua Security now for 3 years and has been building up and sharing expertise in container and Kubernetes security. But that's not enough because she also writes books. She's with the CNCF Technical Oversight Committee and talking all over the world at conferences. So I hope that sums up your work life.
Yeah, I feel like sometimes I have 3 jobs.
Yeah. It's one of those things where we all watch from afar and go, how does she do it? All of these places. So you live on the go for sure. And I did a quick search yesterday on YouTube about just to see like your latest talks, and it's pages. You have pages of videos. So yeah, and it's a lot of it's focused on containers. And my favorite talk is the one I think that you've done repeatedly that you mentioned is about basically you build a container runtime from scratch on stage. Is that an accurate description? Yeah,
in about 60 lines of code in the end. Yeah.
And you use that as a teaching tool, right?
Absolutely, because you can build up sort of step by step all the different namespaces that you use to make what we call a container, and you can do the same to kind of experiment with C groups. And it turns out that in, as I say, about 60 lines of Go code, you can build something that pretty much looks like a container, and it's obviously implementations like Containerd are a little bit more detailed, a little bit more production ready, but it's fundamentally the same technology underneath.
Yeah, and that's all because you're using the underlying features of the Linux kernel. Is that right?
That's exactly right. Yeah. So I mean, a container is basically made of namespaces, C groups, and changing the root. That's pretty much it.
Yeah, and then you add some files. And that's, I always find that's a great introduction. Sometimes it's a little more advanced than people really want. They want to know why they want to use containers. So I guess people have a different way of coming at teaching the beginnings. But there's a lot of magic, I think, sometimes to it when you're brand new to them. And I thought that your approach was a pretty interesting way to give someone the overview of, hey, look, this isn't, there's a lot of automation here essentially, but it's just a few basic features in a operating system that allow this to happen. So
yeah, I'm really one of those people who I want to understand how something works, and from the best way that I've found for me to understand something is to try to explain it to other people. And so breaking it down, rebuilding it from scratch, I just love doing that. And I think also when we talk about security, understanding how something actually works it's almost fundamental to understanding how you can secure it. If you know how it works, then you can see what the weaknesses are, what the possible vulnerabilities are, what the possible attack vectors are. And you can talk about it. But if you really understand the kind of underlying technology, then you can really understand it.
Yeah, I think learning something in order to teaching. Most of us, we don't want to teach something unless we really feel like we know it.
Right.
Because you're always worried that you're going to get that question that you all those questions you're like, I should know the answer to those questions. I don't answer them. So I too also as a teacher, find that I have to learn something way more in depth just to be able to teach the basics of it, because I don't feel confident unless I really know it. So,
yeah.
Okay, we talked earlier before that we hit the record button about what's coming up for you, different conferences. So we have KubeCon coming up, which is one of the biggest events of the year in the container space. It probably is the biggest event now, even if you're not into Kubernetes. And I wanted to show off some of the things that are going on there, because I did not know about KubeSec, and I'm very interested in it. So could you tell me a little bit about what this co-located event is?
Yeah, so this is an event that we at Aqua host, and it's really targeted at enterprise users who want to learn about how to secure Kubernetes. They want to sort of see what other people have done in the real world. So it's a co-located event, which means it happens on what's called day 0, so the Monday of the week, where the rest of KubeCon is Tuesday to Thursday.
Right.
And this will be the fourth time that we've done it, because we've done 2 in the US, and this will be our 2nd in Europe. And in the past, we've had some really great speakers. I was on a call yesterday where we were picking through our selection from the really great proposals that we've had. So I don't know exactly who's going to speak. I don't know exactly who's accepted, but there are some really great brands, some really great people. I mean, one of the talks that we really like the look of is from like one of the big 4 banks in the UK. We got one of the big supermarket brands in Europe. These household names, these giant companies coming in and talking about how they have not just adopted containers and Kubernetes, but giving us some real life experiences around security. We've had really good feedback from them before. We try not to make it, too vendory. I mean, obviously we're putting it on as a company, but we're trying to give a much broader, holistic, we don't want to just throw our solutions down people's throats. We want to give people a broader story about what's happening in the security world in Kubernetes. And looking forward to it.
Yeah, I think it's not a solved problem, right? And with Kubernetes especially. And I feel like there's never an end to the security learning. And so if you're someone out there watching and you're planning on going to KubeCon, I would definitely put this high up on your list, just because especially if you're in the operations realm, right? Like if your job is to maintain these clusters and to build them, I feel like we've had enough bad news headlines in the industry already about companies not properly taking care of their Kubernetes, and so it's complicated enough. I feel like we could do a lot better, and this is one way to do it, is to just have a dedicated conference right next to KubeCon.
That's what we try to do, yeah. And as you say, it's kind of a continual process, right? Because there's a whole range of basic security hygiene right up to protecting from really, really sophisticated attacks. Kubernetes is changing, as you say. Attacks are changing.
Yeah.
There's that continual arms race between attackers and the red team, blue team, attack, defense, new vulnerabilities, spotting those new vulnerabilities, fixing those new vulnerabilities. It's a constant battle.
Yeah, it's definitely an ongoing thing, and I think that the part about Kubernetes, I think that is a little scary sometimes, is that because you don't necessarily understand all the pieces, because there are a lot of pieces to it, especially now that we have all of these operators and all this third-party stuff, I feel like it's becoming its own layered operating system where you have so many different parts to it. We were talking about this on the show a couple weeks ago about how you get enough things connected to it, and you got to be careful that you don't create a brittle infrastructure where you can't upgrade the Kubernetes version because you have all these other things that are dependent upon the versions. And security, I think, is just one step of that. But I think I'm a little concerned about how easy it's becoming, and we need easy, but also that easy needs to come with security by default, I feel like. And I hope that we get to a place, and I'm sure we will, that where the default security out of the box of everything related to Kubernetes, including the ingresses and the operators and all these things, they're just they're all ratcheted down and locked down to the point where it's actually not so concerning if you just set up a cluster and you maybe don't know what you're doing, but you set it up and it's not full of risks. And it's not necessarily like that today, but it's a little tricky, I think, to get right.
That has improved a huge amount in the last 2 years-ish. Only a couple of years ago, people were basically by default installing a dashboard and opening up to the internet, basically. That was kind of the easy thing to do. So fortunately, we have moved on from that. You don't sort of by default end up giving the entire world access to your Kubernetes cluster. And a lot of the things like having secure connections between components, your default installations will set that up for you now, which they didn't a couple of years ago. There are still a few things that you probably want to check for in your configuration, and there are still things that are that need configuration. So things like network policies, pod security policies. If you want to do some kind of admission control, those things don't happen by default. You have to kind of do some work. So if you want to run a secure Kubernetes cluster, it's not going to be a disaster straight out of the box, but there are some things you want to look into and learn about and take care of. And then that's just the Kubernetes infrastructure itself. You've also got to be concerned about the applications that you run on it. The application code may have vulnerabilities in it, and that's something you want to prevent.
Yeah. You actually wrote a book about the infrastructure security. Let me just mention that for a minute. So, by the way, Liz has a great website that talks about all of her stuff, lizrice.com, one of the easiest website domains. Congratulations on scoring that name.
I've been in this internet game for long enough. I could get my own name.
Right. When you've been around long enough, you realize long ago that, hey, maybe the future is my resume is online. There was a moment in my career I remembered where I couldn't find myself on Google, and I thought, oh, if I'm trying to be known in IT, that's probably a bad thing.
The one I'm really gutted about is I didn't get lizrice@gmail.com. So don't email her, because whoever she isn't me. Or she might have been me and I lost the password, because I've tried emailing whoever is lizrice@gmail.com and not had any response. So always been gutted about that.
Yeah, I have, although it might be a blessing in disguise, because I have talked to people that have their name at gmail.com and they say they get all kinds of email that's not for them, especially if they have a short, easy name to spell. It's actually, they feel like it's a negative to have that email address, because so many people have Gmail. It's a thing. But on Liz's site, she has a list of projects, including her Kubernetes security book. And this is... is this about the infrastructure? It's not about the apps on Kubernetes, right? It's about the infrastructure of Kubernetes?
There is a section about essentially vulnerability scanning, checking your images, because that is a huge part of running applications on Kubernetes with some kind of security. We don't really like to say that things are secure, because that's a little bit too definite. Let's say more securely, or... but there is a section about that whole vulnerability scanning.
Yeah, and that's a good segue to talk about Trivy, one of my favorite new tools in 2019. By the way, I learned about this because I asked the Docker Captain's chat what people were using for their scanning, and I had been using Microscanner, which is also a Aqua Security tool, and almost universally they all replied back Trivy was the one they were using. So well done.
Fantastic. Yeah, fantastic. So we basically, Trivy was written originally by a wonderful engineer who's now in my team called Tepe Fukuda, who has moved from Japan to Israel. He's based in Israel with a lot of the R&D team in Aqua, and he brought his vulnerability expertise and his open source project kind of early-ish last year to Aqua, and it's fabulous. It's really good, and it's really nice because it's got the database of vulnerabilities is actually stored in GitHub as well. So not only is the source code there, but you could also go and check if you were interested in a particular vulnerability. It's all available on GitHub, which is pretty nice.
Yeah, that is really neat. And I'm excited about the improvement in support for the Alpine Linux distribution. So that is a big win, I think.
We've been adding support for quite a few different OSs now. So as far as I'm aware, we believe we've got the broadest, certainly in the open source world, we believe we've got the broadest support for different underlying operating systems. So that's pretty cool.
Yeah, that's actually it's an interesting discussion. There was another vendor that I will not name, but I mentioned something about scanning in Alpine and the number of vulnerabilities that come back. Yeah. And I think I was just suggesting that you really need to, if you're someone who's scanning, you need to look at your scanner and look at the industry, because your scanner may be lying to you. It may be telling you things are fine when things aren't fine. And a vendor actually reached out on Twitter and replied to me and said, "Oh, well, you should use ours. It will scan." And I showed them Trivy versus theirs in a screenshot and said, according to this image in Trivy says I have dozens and dozens. Yours says it has 2. So I'm pretty sure yours doesn't scan Alpine as well. You need to go check and check your distributions. And they kind of came back and said, "Oh yeah, sorry, we didn't. We're at it. We'll look into it, our product team," or something like that. So for those of you watching, disclaimer: Alpine, just being a newer distribution of Linux, doesn't have all of the traditional underpinnings of where binaries and packages are located. So if you scan for vulnerabilities inside a container image for like Ubuntu or Red Hat, those often come with, I don't know what you call those, linking tables or something?
There's like the package manager. It's like the equivalent of a lock file, but basically each package manager has its own sort of version of how it records which different versions of which packages are stored. And they're all different. And the sources of data about which vulnerabilities are present, they're all different for different distributions. I think I'm right in saying that Alpine is one that changed their mechanism for recording and reporting vulnerabilities a few months ago. So you need to kind of stay on top of the game when you're doing these vulnerabilities scanners. Yeah,
and we should also point out that there's a difference between scanning the OS dependencies and your application dependencies. I think for someone that's new to scanning, there's a lot going on, right? Like when you just scan something, it's kind of like virus scanning your system to me. It's like, the analogy I would have is we take a virus scanner and we scan a system. We go, "Oh, good." This is, 15 years ago, 10 years ago, we would scan and go, "Oh, good, no viruses." But in actuality, there's a lot of subtle nuance going on there. Mm-hmm. And different scanners will give different results. They have different databases. That's the whole point of the competition of the industry, is that there is no black and white, even opinions on certain things and whether or not they're actually viruses. But when we start to look at CVE vulnerabilities, obviously that's what these tools are doing, right? Is they're just focused on the CVE database?
So when we're talking about the package vulnerabilities, then yes. There are also other sources of vulnerability information. So for example, Red Hat have a separate, they're called RHSA vulnerabilities. So sometimes you'll see in a scan output, particularly for a image based on a Red Hat distribution, and you might see RHSA results as well as CVE results.
Right.
So there's the vulnerabilities that come from these CVEs. So CVE stands for Common Vulnerabilities and Exposures. These get tracked by a database called the National Vulnerability Database, because it's American and everybody has it. They call it national, but everybody internationally uses it as well.
They haven't updated their website. It needs to be international now.
So the NVD is sort of the baseline database of what all these different CVEs are, but it just tells you about what's in the kind of vanilla base version of a package. But that package might be, it's not distributed in the same way. It's not identical from one distribution to another. So Ubuntu might distribute a version of the package with a certain set of patches that's different to the set of patches that, I don't know, SUSE put in their distribution, which is different from the version that Red Hat put in their distribution. And the NVD doesn't know about any of these patched versions. So you have to go to each of those different distributions. They have their own security advisory databases, and you have to look up which patched versions are fixed, not just the base versions. So it's kind of complicated, and there's a lot of different data to try and pull into a vulnerability scanner. And that's just the OS packages. Then you get into things like language packages. So when you're looking at the vulnerabilities in your, I don't know, Ruby gems, or your, whatever you've installed with pip, or whatever you've installed with NPM. And that's a whole other set of data feeds that go into a vulnerability scanner. And then you can, and now we're getting beyond the realm of things that are in open source scanners, but commercial scanners will sometimes scan for things like malware, so actual binary fingerprints, if you like, of known malware, known viruses, like you mentioned. And also scanning for things like sensitive data, so making sure that you haven't baked your passwords or your tokens into an image. So there's a lot of different things that a vulnerability scanner can be looking for beyond just those sort of base CVEs.
Yeah, I'm looking here at, I always like this table, by the way. This is a great table, and I'm sure that it's always challenging to keep it up to date, but there's a lot of the subtlety of these things is, OS packages, application dependencies, all that stuff. And on the Trivy page, there's this great little breakdown of some of the major open source ones. And to me, it just shows how there's a lot of different things going on, and it's not just about whether it tracks things, but also, is it suitable for CI? Does it run inside the container or outside the container? Does it have an easy to use command line that doesn't require a lot of setup? So yeah, definitely, I think we could probably do a whole show on just scanners and showing different examples. But yeah, I'm glad you all have been supporting the Trivy project, and congrats for that, because I think Alpine, just at DockerCon last year, I had a Node.js talk, and I was covering lots of things about Node.js and Docker, and I got to a slide that I was like, okay, here's some big hitters on DevSecOps stuff where, if I'm not that expert, but if you want to go looking into these things, here's some scanning. And I didn't know about Trivy at the time, and I was giving a big warning about, if one of the reasons you want to be concerned with Alpine is if you're going to switch to that, your scanners may not be truly scanning the dependencies yet. That's not a solved problem. And people love their distributions. So I got some people that were didn't like that I was I guess throwing a little shade on Alpine, and it's not Alpine's fault. It's just that the industry in that area isn't matured enough. But it's great that they're changing it, and it's improving, and we got better tools now. So it's amazing what can happen in 1 year, going from one conference just 8 months later, and we already have such a better situation with this. And now in my future talks, I can talk about that there are ways to solve this problem, because scanning your Alpine image and it saying 0 vulnerabilities when there's actually lots is, I think, I think the worst outcome, because feeling safe when you're not safe. All right, so we've got this other tool that I have to admit I know very little to nothing about. I've sat in some eBPF talks before, but they're quite frankly pretty advanced for me. So for a new person to, is it the Berkeley packet filter? Is that what eBPF stands for? Break this down to me. What's Tracy all about?
Right, yeah. So I'll start with the eBPF part and then move on to what Tracy does. So Berkeley packet filter was originally a mechanism in the kernel that lets you take it as a network packet is kind of traversing through, look at it and decide what to do with it. So really fast decisions about whether you're going to drop a packet or send it somewhere different or manipulate it in some way. And in order to make those decisions, you're essentially running code in the kernel. Like, even if it's a very simple test to say, if it's destined for a certain address, drop it on the floor. And that, somebody realized, I can't remember who the name of the person, but somebody realized, well, you're running basically arbitrary code in the kernel. So maybe we could do some other things, not just look at network packets. Maybe we could look at other things that are happening in the kernel and run arbitrary code in response to them. So now there's a whole ton of different events inside the kernel that you can attach. It's called extended because it's extended not just to packets, but all these other events. You can attach your piece of code to run when these events happen. And those events might be things like entering or exiting a system call, and a system call is a function that's happening inside the kernel. You can attach them to arbitrary trace points that you put in the kernel. There's all sorts of different places where you can attach eBPF code. And because it's running in the kernel, it goes super fast. So a lot of people have used it for doing various observability tools. There's a giant, enormous family of different observability tools. You can look at, network traffic. You can look at what's running on your host. You can look at, there is no limit. Anything that's happening in the kernel, you can pretty much observe with these eBPF, arbitrary code, these programs. And what we've done with Tracy is we've attached, we're basically using it for observability purposes, tracing events like system calls, but we've made it really easy to, you can trace the whole host if you want to, but you can also just trace what's happening inside containers. And that's super useful if you want to do, for example, you want to see whether one of the events that we hook into is a thing called cap capable. And this is when the kernel checks whether or not you have capabilities. This is like permissions. And you might have heard of being able to drop capabilities when you're running a container, either in Docker or in Kubernetes, because you don't necessarily need all these permissions, right? So there's an example of a cap capable event going by on the screen behind us. Yeah. So those cap capable events actually show what capability is being requested. So you can run a container, see what all the different cap capable events are, see what all, does it need all the capabilities? It probably doesn't. You can check with Tracy, and then you can configure your container to run it, dropping the capabilities you don't need. So it's pretty experimental still. Yeah. But that's just an example of the kind of thing that we can do with Tracy. We can look at, you can see all these different system calls going past. Another example of something you can do is look at exec-VE events. An exec-VE is the system call that happens when you run a program. And when you run like an executable, and inside a container, you probably only want to run 1, 2, not many different executables. My favorite example of this is Nginx. If you're running an Nginx container, it runs one program, and that's called Nginx. So if you were to see a container running something else that wasn't Nginx, it should be at least a red flag. You don't expect that Nginx container to run anything else. And you can observe those exec events really easily with eBPF. This is actually what Falco does for observing events that you can subsequently flag as kind of security violations potentially. With Tracy, we wanted to build something that was much simpler and much more sort of lightweight for people it's not something that I expect everybody needs to use, but if you do want to explore the capabilities or the system calls that a particular container uses, then Tracy is a really easy way to do that, where maybe Falco is a bit more kind of a bigger system, if you like.
Yeah. Would it be accurate? I'm kind of thinking of this because I was thinking of Falco as well as a tool that's kind of related, but I almost feel like Falco is an operations tool, and it sounds like what this could be is something that you're using as a sort of an analysis tool before you go with an application. Because if you're trying to reduce capabilities, you would probably want to do that during your testing phases when you're building an app initially or about to deploy it and build your Kubernetes, manifest and stuff like that. Is that kind of how you're thinking about it?
Exactly. Yeah. Okay. And you'll probably see on the Tracy GitHub page, we've still got a giant experimental label on it because we're still figuring out all the different things that people could use them for.
Yeah.
It's definitely, it's on the kind of more advanced end of what you might want to do when you're using containers, but we think it's got quite a lot of potential. There's so many interesting things you can do with eBPF, the fact that you can see all these different events happening in the kernel. And Tracy is quite a nice way of exposing some of those. I think there'll be a lot more to come.
Yeah, it sounds really cool. I'm sitting here thinking about, when you talk about code coverage with testing tools, some of them are fancy enough to actually show you how much of your code the tests are touching. And so there's like parts of your code that aren't properly tested, and it'll kind of warn you of that. And often when I think about these different profiles, we have the app armor and the SE Linux, and we have the Linux capabilities, and we have all these different parts. Some of these things do the same thing in different ways. But fundamentally, it's all related to the fact that I'm running an app in a container, and the container has various sets of permissions inside the OS, and there are things that it's doing, and then there's the things it can do, and there's usually a wide gap, right? And one of the things I loved about Docker early on was when I started to understand that there were all these templates that just I think largely Jesse Frizzell was using or building,
like the seccomp.
Yeah, the defaults, and we don't realize these defaults of the seccomps and the app armor profile and default capabilities. That Docker locks all that down, but the way that it did it, at least my understanding is that engineers like Jesse went and took a bunch of these, just a bunch of random apps out there, and then ran a bunch of them, found what things like capabilities that they didn't need, and gave defaults to Docker that are reasonable for most people. But the reality is, like you're mentioning here, is that a lot of us could change this. But when people start asking me, well, how do I change this, and how do I find out what I need? I do the shrug emoji, because I'm thinking there's probably tools out there, but I don't know them for discovering what here's what your app has in a container, and this is what your app needs. And someday I'd love to see a visual. Can I just put in a request for Aqua Security products? That there's this tool that basically says, okay, here's what your container is giving your app, and this is what your app is using, and here's the wide separation between the two. And here's a nice little capabilities list or app armor profile or seccomp profile or whatever. Here's your stuff. Go ahead and add it to Kubernetes, and your app will be more secure. That's like the easy button to me. So
yeah. I think that default profile, and you're right, Jess Frizzell, I think she ran hundreds of different applications to check, because there's a ton of these system calls that a container has no business messing about with. You
right.
Probably don't have any reason for your container to reboot the machine, so why give it permission?
Right. Well, and it's even worse before containers, right? We were giving all these apps, especially ones that were running as root, which they obviously shouldn't have, but these apps have so many abilities that and that's the thing, like all the operating systems are doing it, the desktops are doing it, they're all slowly figuring out, okay, let's just not give you anything out of the box, and then you slowly have to, we're basically in a world of pop-ups now of, do you want access to the mic? Do you want access to like in Mac now, it says when apps launch and they want access to the downloads folder, it says, would you like to give this app permissions to the downloads folder? There's we're getting closer and closer to that friendly experience of secure by default. But the key there is we have to get it friendly. And I think friendly for us DevOps people means that we have a tool like a scanner that educates us on not just what we're currently doing, but also the difference between that and what the defaults are. So let's mention Falco. You mentioned Falco real quick. I just want to go back to that because it's also a tool I love to recommend. And so for those of you out there, this is a tool that is now a project with the CNCF, but I think of it as an operations tool that allows you to see things that are going on in your clusters or just even on a Docker server, anything that's running a container that is something maybe a behavior that you're not expecting, such like someone's running an exec command or Docker exec or kube control exec or something like that. And one of my favorite features of it is that it comes out of the box with some defaults, because that's always the hard part of getting into security is you don't know what the right choices are. And you don't even, a lot of times some tools are really unopinionated. And so I like opinions sometimes. And this tool has a little bit of an opinionated default. You can use some templates you can use that will give you some basically logging that you can look at. And this is related to a question we have from our audience. I'm going to throw this one up on the screen. Hey, Liz and Bret. Oh, well, this is let me shrink this question down. Is there a way to identify a rogue container that is running in production, and what are some of the ways to isolate it or fix it so that it causes minimum damage?
Right. So this is one of my favorite kind of topics, and it's kind of cool that you have Falco there, because Falco can tell you when something is happening that is unexpected, like a container running an unexpected executable. What it can't do is prevent that from happening.
Right.
And there's this is the kind of chasm between what you can do in open source and what the kind of commercial security tools can do for you, because the commercial tools hook into containers in a proprietary but very, very powerful way. And I say the tools, and not all of them do, but certainly Aqua and some of our competitors do, where, we saw with eBPF and with Tracy, you can see that exec VE system call happening, and you can report on, here is a rogue executable. And Falco can do that, and it can tell you it's happened, it can send you an alert, and then you have to decide what to do about it.
Right.
With something like Aqua, you can stop it from happening. So that exec VE system call does not get to actually succeed. And that means it never got a chance to do any damage. Now, you've got to have a profile that says, this is what I'm expecting my container to do. But that's one of the big differences between, it's why enterprises pay money for security products, because they're looking for that preventative approach.
Right. IPS of containers. Yeah.
It is exactly IPS for containers. Yeah. So if you have, the budget to do it, that's kind of the best way to prevent bad things from happening. You also have to go through the process of, profiling your containers so that they, we know what good or bad behavior looks like. But there's lots of really cool things that you can do there with preventative security. And if you want to say how to fix it so that it causes minimum damage, that's the best option.
Yeah.
The other thing that I would say about identifying a rogue container that's running in production comes back to that idea of vulnerability scanning. So if you know that you have an image that's bad, that has, whatever today's heartbleed or shell shock or whatever is, you want to spot those containers that are based on that image as quickly as possible and replace them with a new version with the patch. Because nobody patches containers. You have to rebuild your container image and redeploy the container, redeploy your pod in Kubernetes with that fixed version. So that's another one of those management tools that it's easy enough to do if you're running 5 containers, but if you're running 50,000 containers, you probably want some tooling to help you identify okay, so scanning found these issues. Here are the containers we need to worry about that are running those images.
Yeah, and I think tools like that, I mean, I'm sure you've been in these projects as well. Big companies like to buy tools, and that's a good thing. Often what I find is that when they buy a tool like this container IPS, I don't know if that's actually a term in the industry, but I'm going to call it that, where it actually requires the team to do more discovery and learning about their own systems, because a lot of us, this stuff is so new to a lot of us that we set up a cluster, everybody's launching things, we're running things, maybe we're working on trying to get automated CI, maybe we're trying to get to GitOps, and all along the way, this great question has never really been asked of, how do I know when there's a container on here that I don't want? And really, it was the same question before containers. How do I know if there's a binary running on my server that I don't want? And because obviously these containers have to run on an OS, so the OS still needs to be monitored at some point. And it's a great question because it goes down a rabbit hole of how much you don't know about your systems.
Yeah. I think it's one of the nice things about a containerized system is you do at least have these kind of sort of isolation blocks, right? So, if you're going to have a host and it's, you don't want to have a mixture of like some applications and some containerized applications. You want to have everything running containers. So that anything that's actually running on the host should be the things that you need to run your containers, basically.
Right.
And then inside each container, you've got these isolated, limited sets of application code, and you can start reasoning about what is expected behavior in those different containers much more easily than you can about like what's expected behavior on this entire giant server if in a traditional non-containerized environment. It gives us, in the same way that people talk about microservices architectures breaking things down into sort of manageable two-pizza team problems, it breaks down the security problem into sort of more manageable chunks as well.
Yeah, and really what we're talking about here is whitelisting, and I've always loved whitelisting in every sense of the word, like Apple's iOS store. I've loved the fact that it was everyone, people that were creating apps didn't like that they had to get it approved, but I always preferred that because I'm not looking at the code in these apps. I hope someone is. And the industry has kind of, I think, responded in general to that. I don't know if you know Mark Rasanovich from distinguished engineer at Microsoft. I think he's head of Azure now or something. Engineer at Azure. He always, a long time ago, he talked a lot about whitelisting. He was one of the first engineers, maybe a decade ago, that I listened to him talking about that we've never, in all of tech IT security, we've never really come up with anything more secure or a safer paradigm than whitelisting applications, whitelisting code. And it's hard because I can see why there's the argument against it is who's got the time, right? Who's got the time to approve everything? But one of my earliest experiments back in mid 2000s was getting this is a little bit off topic, but Microsoft Windows and the group policies, they had this tool where they would allow you to whitelist the apps on a machine. And somewhere around 2008, 2009, I started doing that at companies where we would lock down everything. And it created the project of all projects, because when you start looking at a desktop machine and how many applications are running on it, it's a nightmare. And if you start looking at an enterprise, it's a huge nightmare. So I imagine if most of us just turn these tools on our servers, we would be shocked by the number of binaries, right? If you got 100 servers and you've probably got thousands of different binaries running. So I like the idea
and
that
that's actually coming back to like what you were saying about Alpine. One of the nice things about Alpine is they reduce the number of binaries that you're sort of installing into your image just by using whatever distro.
Yeah, no, that's an excellent point. Excellent point.
Even smaller.
Yeah. Certainly, when you install Ubuntu, and which is my example for everything, and then you do a PS AUX or something, and you look at this list of, I'm running nothing, but there's 100 binaries running on my server. Which one of these is bad? That's a really, it's still fundamentally today, it's not an easy question to answer.
Right. Yeah. So breaking those lists down into smaller sets of things that you can kind of get your head around is important for a security person.
Yeah. And I like your advice. Paid products take a lot of the time out of a lot of this stuff. Open source is great, but I think paid products always give you your time back, essentially.
Exactly. Don't get me wrong. There's plenty of really good tooling out there that's open source, but the reason why people get to a point of scale where they need that extra management or they need that extra capability. There are enterprise features in all kinds of commercial products that people need that they can't get from open source, and that's kind of how a lot of us get our paychecks, and it makes the world go around.
That we can make the open source. That supplements it. All right, I've got a bunch of questions stacked up here. People are loving the security topic. So let's see if we can do some quick hitters. Someone asked a question about secrets in HashiCorp, but I'm not sure we're going to have an answer for that, so I'm going to skip that one. Sorry for you if you're waiting for that answer.
I could answer in one sentence. HashiCorp Vault is a great place to store your secrets.
Yeah.
Ta-da.
Yeah. If you can implement Vault, you are already so much more advanced than the average shop. So bravo. Yes. Not storing I just was told by a friend last week that he works at a boutique hotel, and I won't name names, but that he learned at his job that his management stores all their passwords in a spreadsheet for every user. So, the world still has these problems, and we're here, talking about Vault and eBPF. So,
well, actually, the first time I did a talk about secrets management once, I did it a few times, and the first time I gave the talk, I had sort of flippantly talked about, obviously it would be a really bad idea to put your passwords in source code. And I looked up and I could see people writing it down. I'm thinking, people do. People haven't thought about that. It's I think people realized that putting them in their source code on GitHub was a bad idea, but they didn't necessarily think that private source control was going to be so much of a bad idea. And it's obviously not as bad as putting it on the public internet, but it's still bad. You're still, everyone who needs to see your source code is not the same set of people as the set of people who need to see your passwords.
Yeah. Never mind the fact that when that thing needs to be changed, there's a small group of people that know how to change it because they're the ones that have to edit the source code. So you're creating a maintenance nightmare as well as a security one. I know. There's we can say the obvious, and it's only obvious to some people, right?
Right.
All right. Is eBPF open source to use and safe to use in production when we are using Docker Swarm setup?
Oh, okay. So eBPF, eBPF is basically a Linux kernel capability. So it's open source like the rest of the kernel. There are lots of eBPF utilities that are also open source. There's a whole set of things under github.com/iovisor, IOVISOR, I believe. And there's a bunch of useful observability tools. There's a thing called BCC, which kind of helps you write your own eBPF tools. So if you want to go and explore eBPF, that's a really good place to start. Also, the other reference I would say, if you want to explore eBPF, apart from looking up my talks, obviously, go and look up, there's a chap called Brendan Gregg who has done a ton of work on eBPF, and really he's written a great book. He's got this really tons of resources on his website, which I think is brendangregg.com. So he's a great resource. Is it safe to use in production? Well, yeah. So one of the really clever things about eBPF is it does this validation before you can run an eBPF. I talked about running arbitrary code. It checks that code is safe to run to completion because it's going to run in the kernel. So it must not crash in any. That would be bad. That would be an unhappy day if you crash the kernel.
Right.
So The validation step looks for things like you can't dereference a nil pointer, you can't get into an infinite loop, you can't write into memory except under some very limited circumstances. So basically eBPF is sort of by definition safe to run.
Right.
Yeah. So
there's been an increasing number of talks over the years as eBPF sort of rises to the top of solving so many of these problems that traditionally were really hard in terms of plugging stuff into the kernel. So it's one of those things like on the long list of things I really want to learn is I want to experiment with some eBPF tools and learn about some of this stuff. And it doesn't happen. But the nice thing is, like Brennan's, a lot of this stuff, it's all on YouTube. A lot of these talks from the conferences are on YouTube. So I imagine if you searched, eBPF and Brendan and Greg's name on YouTube, you'd probably come up with some talks on there. I would expect.
You would.
All right, next question. Early 2019, Aqua released tools to help assessing Kubernetes cluster security like KubeHunt. Are these tools still under development? They really helped me to be aware about the security.
Yeah, so KubeHunter, KubeHunter it's actually pretty cool. I really like it. It's like run your own penetration testing. So you can fire up KubeHunter against your cluster, and it will basically try to hit different APIs and see what it can do. And so, for example, in the old days when you had a dashboard open, it would report back. It's looking at the port where people would normally run a dashboard and seeing whether you can get anything. So yes, it's still something we're working on. Still, actively trying to add hunters and make it better. It's also interesting because you can run it either sort of outside of a cluster, or you can run it inside a pod in a cluster. And then that's giving you the view of what an attacker would see if they managed to compromise that pod. So if you had a vulnerability that allowed somebody to basically open a reverse shell into that pod, what could they do? And KubeHunter kind of explores. There's probably plenty of more things that we could add more hunters to discover, but it's basically trying to explore whether you can make API queries from within that pod, that kind of thing.
That's really cool. I don't think I fully understood what this tool was, and now I'm excited. Because it's another one of these tools where, kind of like the scanners, you have everything's a black box, and then you run one of these tools, and I'm guessing that this is probably a 15-minute setup kind of deal. You learn a little bit, read a little bit in the README, and then, like it says at the top, do not run this on Kubernetes cluster that you don't own. I learned many years ago, I'm dating myself decades, running Nmap on a corporate network without permission, don't do it. And that you also shouldn't run KubeHunter on someone else's cluster. Don't run it in your company if you don't maintain the cluster. But anyway, these tools, I love when it within minutes of running something, you're getting back information that taught you about your own tool, your own infrastructure that you didn't know, and giving you visibility into what's going on there. Because when you start looking at like Kubernetes the hard way from Kelsey, you realize that there's tons of certificates, there's endpoints, there's all these listeners, and if you don't really spend some time poking around in it, tools like this could really be a time saver. So I'm glad that question was asked. That was definitely a great question. KubeHunter.
I think actually it's a really positive measure of how Kubernetes has come on, in that when we first released KubeHunter, you could, any sort of vanilla new deployment, you were pretty likely to find something with KubeHunter. The defaults have improved to the point where you're much less likely to out of the box find something. You might though.
Yeah, that's true. Well, and your installation method, right? Like which installer are you using? I've been spending all this week with micro K8s from Canonical, and it's amazing how each one of these setups is a little bit different. They all have, some of them come with core DNS, some of them don't have it by default, some have the dashboard by default, some don't, and understanding your distribution, I think, is definitely a requirement before you go production. And I think this would be a great tool. It sounds like it's a great tool to set sort of a standard for, okay, I'm now on my local machine, but now I need to build a cluster and I use some tool, kubeadmin, some distribution. What does that look like in production? And of course, a security team always loves it when DevOps people show them reports of security scans, like without them having to ask for it, right? When you volunteer information, the security people will be your friends. Cool. Yeah. Yet another tool on the list for me to play with. All right, next up, what security risks that... let me make sure I get the question right. What security risks that can impact my Kubernetes cluster if I run Nginx container with root privileges?
All right. Okay. So hopefully nothing's going to go wrong. But first of all, let's hope that the Nginx container doesn't have any vulnerabilities in it, either in the Nginx code itself or in the base image, whatever. I can't remember what the official Nginx. I want to say it's a Debian image. I might be wrong, but there will be some Linux stuff going on there. And if you take the sort of vanilla Nginx containers, now it's going to run as root by default because Nginx has been around for longer than containers. And I say that somebody will probably come up with some.
It is the internet.
But I'm pretty sure people were using Nginx very widely before they were using containers very widely.
For sure. I'll support you on that one.
Yeah. And Nginx is by default going to open port 80 because that's the standard web port. And in order to do that, it needs a one of those capabilities that we mentioned before, something bind port something, can't quite remember what it's called, but so it needs this capability. And if you're root, you have that capability automatically. So the easiest thing is just run it as root. And if you were running Nginx on a server, that made sense. You were going to be opening a web port. You might as well have a privileged user running that service. If you're inside a container, it doesn't really need to be root because you're inside a container. The important thing here is that if it is root inside a container, that root is root. The user 0, unless you've got user namespaces, which we can go down that rabbit hole if we want to, but for most of us, you're going to have the 0 ID user root inside a container is root on the host. So if there's any way of escaping that container, you escape out onto the host and you are already root. So then game over, you can do anything you like. So how can you escape out of that container? A vulnerability, some unexpected exploit that's been built into that image. Bad configuration. So maybe you mount, there's an example that I quite like to demo where you can mount the etc directory from the host into the container. And then if you can get that root user can then create new user identities, create new passwords for them. And then you can just, access the host if you want to. You can log into the host. So coming back to the question, if you run an Nginx container with root privileges, maybe nothing is going to happen. Maybe nobody can exploit that container. Maybe they can't even get network access because you've got beautiful firewalling and VPCs and everything. But if somebody manages to breach to the point where they can run code inside your container, you may as well have given them access to the host.
Yeah. So I'm trying to think if I can summarize that. Okay, so step one, the application has to not have any vulnerabilities, and then if it does, then they're going to possibly be root in the container, and that depends on the app, right? I mean, they are asking about Nginx, so we assume that Nginx, and Nginx itself is actually got worker processes that run as non-root, so you'd have to break through the worker process and get into the root process that runs Nginx, and then, like you said, then you'd have to break out of the container. There's so many different levels to it that I think it's a hard question to answer, because, like, was he implying that the root, the container itself was running as root, or the Nginx in the container was running as root? Because we're talking about inception here. When we talk about containers, there's many things running in many things.
It's an extra layer of defense, and a very important extra layer of defense to try to run your containers as non-root, because it's because these vulnerabilities happen, and you can't assume that there will never be another, I don't know, shell shock or something. There could be a giant, really awful vulnerability that means that anybody can open a reverse shell into, a container.
Yeah.
And if that container is running as root, as soon as you've got shell access, it's going to be bad news.
Yeah, and this is maybe a good time to mention that there is a feature in Docker that it's called user namespaces, largely written by our friend Phil Estes. Go Virginia! That feature allows Docker to run the containers as a non-root user on the host. So even if the Nginx is running as root in the container and it tries to break out, in some cases, then it wouldn't matter because they're not root on the host. Obviously, you wouldn't want them to get out of the container at all anyway. So a lot of these questions are great questions, and I'm not telling people they shouldn't ask them here, but I do have a list of sort of my top 10, like, day one with containers. What should I do to make this more secure? Things like running the app as non-root in the container, running Docker itself as non-root, and it goes from the easiest to implement to the easiest to implement and the most bang for your buck to the hardest to implement and possibly the least bang for your buck. Like, a custom AppArmor profile probably shouldn't be the first thing you do with container security, because that's advanced and maybe won't give you a lot of bang for the buck. So I'll put this in the chat. It's the URL for the podcast is bret.show/security first. And it's basically a GitHub page issue that's just a list that I keep up to date on what are the things I should be looking at. And we're not talking about Kubernetes. This is just really about basic container running. What things can I do to really help my team stay safer than the average person running containers out there? So that's bret.show/security first. All right, so we are already at an hour, and we have a ton of questions. So I want to give you a couple of quick flyby questions, and because we don't want to run too long. But let's see. If it is GitHub like this and it is open source, as to how safe is it? Not sure. That might be a question for someone else. Let's see. Oh, how Tracy can be used with Kubernetes. Please provide use case for that.
Okay. So you can. Somebody in my team has been looking at kind of creating the kind of Kubernetes pod spec or a job or something to run Tracy, to make it easy to deploy in Kubernetes. But for now, let's assume you would just run it on the host, and you can run it in a mode where it will just follow events inside new containers, and you could then that will include any containers inside Kubernetes. We don't right now have the ability to follow specific pods or something like that. That's, for example, something that we might do.
Okay. Yeah. The ideas are probably limitless.
Yeah.
And the question is, people on the project to support open source.
Yeah. Contributions welcome. Yeah.
I wasn't going to say it, but PR is welcome. This is actually a great. I'm going to have two questions left. The first one is from Marcos. When are we going to see an OCSP top 10? Open Container Security
like
Project
the
Top 10.
OWASP equivalent. I like it. Yeah.
Jokes aside, what is your opinion, the top 3 container vulnerabilities?
Oh, top 3 vulnerabilities or top 3. I would say
Vulnerabilities, or are we talking about CVEs, or are we talking about just like problems that need to be addressed?
I'm going to assume it's the latter, problems that need to be addressed.
Yeah.
So I would bundle up the set of, vulnerability scanning, the vulnerabilities that affect everybody else. In fact, actually, that it would be interesting to take the OWASP top 10. Maybe I'll do this one day and kind of map how that relates to containers, because a lot of the things that are in that, like SQL injection, SQL injection applies to containers as well. It's there's no reason why SQL injection would magically be different just because your code is running in a container.
Containers don't save you from bad app code.
Yeah. But maybe there's a set of things that are specific to containers that we could put a list together. And I think it would depend a lot whether or not you were talking about Kubernetes or not Kubernetes. So, for example, in fact, I forgot to say this earlier when we were talking about seccomp. So, seccomp default profile that we love does not run by default in Kubernetes. You have to apply it to your containers through annotations, or to your pods through annotations. And that might be one of my top 3, I would say, if we were considering Kubernetes.
That's a great tip. When you're making your manifest for Kubernetes, make sure that you enable the default. Are we talking about the Docker default seccomp profile?
Yeah.
Which is an unfortunate default. It's too bad it wasn't. Yeah. It's too bad it wasn't enabled by default.
I think so. Yeah.
And it's too bad you couldn't do that universally and just say this cluster all uses this seccomp profile by default in Kubernetes. That would be that's on my wish list. And to me, I think definitely the top one there is exposing the Kubernetes API port, exposing the Docker TCP port. Like, don't do those things. We now have SSH tunneling in so many different ways that if you have to have something accessible from the internet, just do that and use SSH keys to do that instead of. I mean, VPN and, just preventing things like in that way used to be the traditional answer, but nowadays a lot of people they want to have remote access to it, as do I. So a lot of times people expose those ports when they don't need to. But yeah, that's a great one. I'm going to have to add that somewhere. I'm going to put it in my courses or something. Enable the seccomp. All right, and the last one is a kind of an open-ended question, and we'll leave it at that. I lost it. Okay. How to introduce container security to people we knew that know containers, and if they're learning containers, and I'm paraphrasing, and they're learning Kubernetes, there's a steep learning curve. So it makes people angry when you introduce security too early. How do we, I guess, remove the hostility of introducing container security or just containers in general to someone who's concerned about the security?
Yeah, this gets to the heart of the whole, the word that has been coined, DevSecOps, doesn't it?
Bring donuts.
There's people, and they all need to be involved. There's security people who, traditionally have been the people who lock down, ports and networks, and now people come along with these containers and they kind of go, I want all the ports. Open all the ports, please. And I can't tell you what port I'm going to use. It's orchestrated. I don't know. It's no wonder that security people kind of need to be brought along on this journey and sort of understand about the benefits as well as the kind of, because it is a change in mindset. So yeah, it's not a quick answer, I think, but I think involving people early on and if we think about why businesses move to containers and why they move to Kubernetes, a lot of it is about agility and the ability to deliver, new capabilities for their business quickly. And security, I don't believe anybody in security wants to be slowing that process down.
Right.
But they've often got this responsibility. They're the person who, if they get breached, they're going to be on the hook, right? And so they need to be given time to learn about this new mechanism, all these new mechanisms and all the new behaviors and processes that come along with containers and Kubernetes. You can't just expect people to kind of accept it.
Yeah.
Without question.
Yeah. The words, just trust me, don't often work with a security team. Yeah. I feel like it's a people problem more than a tool problem.
Yeah.
I mean, generally, security people are humans like the rest of us. If they feel like you're hiding something or you're not given the full, if they're having to pry information out of you, that's usually going to be a rough start to a project. So, the biggest successes I've had with working with security people is always including them, having special meetings just to educate them and to answer their questions all along the project, making them, inviting them to meetings they don't even need to be in. It tends to go better than the alternative, which is to exclude them, only invite them at the last minute when they need approval. Like that may save you a little bit of time up front, but it will create a lot of headaches later. So I feel like the agility of these tools, though, especially if a lot of companies are implementing, like you said, implementing containers for agility, and there's a lot of them out there that are skipping steps, right? Like not in a bad way, but meaning, we're wanting it for microservices and all these other reasons, and we're implementing containers as a byproduct to all these other things we want to get done. And that doesn't always, like you said, it doesn't always allow the learnings that need to happen, the evolution of learning. And sometimes the security people, because of they're obligated to do things like security scans, system scans, and code scans, and all these things. And if you deliver to them with your ideas of these containers and clusters and all these things, if you're delivering as well, here's some of the security tools we will add to our tool list that we will implement into CI and blah, blah, blah. I always find that's a much easier acceptance when you say, oh, we're going to be improving your visibility into all the things we're doing as a part of this project, instead of adding all these new layers of tech that you don't understand that are obscuring your view. Because I think, certainly at first, containers seem like, when you don't even understand what a container is, container seems like a thing in a thing, and you can't see into it, you can't get visibility. And my first day with after they learn the container basics, I'm always trying to show them and demystify the this thing is hidden from your view. No, actually, if you're on the host, you can see all these things. They're all there. You can see what's going on there. And I try to reduce that fear. But you're right. I mean, this question is great. People can get angry. But so you want them along for the ride, and I think it's different for every team and every project a little bit, because it's personalities, it's people. So, that's a great answer, great question, and great answer. Thank you so much for that, because security is hard, and we're all trying to be better at it. Let me give you all a few quick reminders. So at the end of this, we're talking about Trivy, that's a great tool that you all should definitely check out. And at KubeCon, if you're able to make it to KubeCon EU this spring, the KubeSec conference will be there as well. And Liz will be speaking at that event, as she does at all container events. She's obligated, I think, to speak at every container conference in the world about cool things and all things security. We talked about a lot of other tools you'll get in the description later. If you come back to this video after the fact, just look at the description below. You probably already did that if you've watched this far. And where else can people find you on the internet?
So they can find me on Twitter. I'm Liz Rice on Twitter. I have my website, which I fail to maintain as well as I would like, but it's not that bad. LizRice.com. It's pretty much me. All
right. You and our Twitter profiles are right below us, so you can reach out to there. And Twitter is a place where we all hang out. And
it is.
Yeah, and I'm looking forward to seeing you in the real world at KubeCon or some future clustering Kubernetes containers microservices event, whatever that is. And
we always see each other at some container event. Yeah.
Yeah, and in fact, we might actually. One thing I did want to mention to everyone: Docker did announce DockerCon will be virtual this year, so we won't be able to meet in the physical world. but we will have it in the virtual world. And Liz and I actually, I think the first time we met might have been at DockerCon.
Sure it was,
so we've been around that for years. So everyone pay attention to the news out there from Docker, because I think they're going to be sharing some more stuff soon about that event and opening up call for papers. Want to make sure I got that in there. So thank you so much, Liz, for being on the show. I'm looking forward already to the next time.
Yeah, that's been fun. This was my first ever YouTube live, so it's been really fun.
I'm glad you joined me for that trip, because we have a great audience, and I'm glad everybody showed up with great questions. So thank you to the internet out there, and we'll be back here next week or some Thursday here in the near future on YouTube Live. Thanks.
Bye.